So very good morning to one and all present here. I'm very glad to see all in the second phase of the AICT sponsored 1 week short-term time frame program on the topic IoT based manufacturing and design challenges and opportunity. Since it is the second phase and most of the participants are from the phase 1, we are not going for a detailed inauguration session. We are going to have only a shortened inaugural function, and then straight away we are moving on to the technical session. On behalf of the entire Vishwajyoti community and Vishwajyoti family, let me invite each and every one of you for this short-term training program. And we all of you know that this short-term training program is mainly based on the IoT concept. That is the thing we are going to deal with Internet of Things, Industry Internet of Things, big data, data analytics, Industry 4.0, then augmented reality, virtual reality, and smart manufacturing as well as digital manufacturing. So these are some of the concepts what we are going to see in the next 1 week. As we mentioned in the phase 1, in the phase 2 also we have a blend of academicians as well as the people from industry who are very well versatile in their area of research and topics. So without much delay, let me once again welcome each and every one of you for the second phase. And also I like to thank few people who are associated with this Sttp. First of all, I'd like to thank our chief guest itself, Dr. Somashaya sir, because he is also one of the main important person who associated with this Sttp. Thank you very much, sir. Next, I like to thank Dr. Murugarajan sir, who is the brain or the mentor behind the faculty of this short-term training program. Thank you very much, sir. Next, I like to thank Dr. Sriram K. Vasudevan sir, who is also the prime important person behind this Sttp. I'd like to thank Sriram sir. Next, I like to thank all my fellow colleagues of Vishwajyoti family and my own department, mechanical engineering department, for assisting me in organizing this faculty development short-term training program, and successfully completed the phase 1 and moving to the phase 2. So with this, let me invite Farnosh K. Francis for introducing the speaker.
Good morning all. Today we are starting the second phase of STTP on the topic IoT based manufacturing and design challenges and opportunity. The first session for the day is a talk on robotics, past and present, emerging research and challenges by Dr. Somashaya S. Hemant, Associate Professor from Department of Mechanical Engineering, IIT Madras, as the resource person. And we are delighted to have such an eminent person for our STTP. Dr. Somashaya received the doctoral degree in 2004 from Indian Institute of Technology, Madras. He has published more than 150 papers in national and international levels. He has delivered more than 75 invited talks on various topics of his research at engineering colleges, universities, research centers, industries, and conferences. And currently, he is handling many consultancies and sponsored projects of various industries and R&D institutions of defense, Government of India. His current research area are mechatronic system design, system simulations and modeling, robotics, finite element modeling, basic fluid structure interactions, micro machining, advanced machining process, basically hybrid process and fluid power system. He has received so many awards like Innovative Students Project Award 2005 from INA New Delhi, Professor K. Armugam National Award ISTE New Delhi, and received the Certificate of Achievement for Guiding Best MS Thesis from INA. And he has published so many research papers. He has 2 patents. He has published journals in 56 reputed journals. He has more than 130 international conferences. He has published 3 books, book chapters, 4 book chapters, and guided 11 doctoral students and 5 MS and 43 master students. So I welcome you, sir, for this first section.
Thank you very much. Thank you very much, sir. Thank you. Thank you. Audible, no? I am audible?
Yes, sir. Yes, sir.
Yeah. Shanmugesh,
Yes, sir.
shall we start now?
Yes, sir.
Yeah, I will share my slide. Yeah. Thank you so much. My slides are visible now?
Yes, sir.
Full visible?
Yes, sir. It is visible, sir.
Yeah. Shall we start now?
Yes, sir.
Very good morning to one and all. Many faculty friends are already attended my first talk in the first phase of the FDP course. Assuming that, we'll move today on robotics, past, present, and future emerging challenges. What are the things we are seeing from the olden days and what we are seeing currently and what we are seeing in the future, we'll discuss today, friends. Shanmugesh, it is audible it is?
Yes, sir. It's okay, sir. Fine, sir.
That's what I'm telling you. You have to tell me, okay? Now, this is my quick glimpse of my presentation. Very quickly, even though all friends are same, and I will give you about, as usual, our laboratory and focused research areas, and my autograph, which is very important now. Okay, robotics, past, present, and future we'll discuss, and lights on the industrial robots, how it is and how it was and how it should be. Similarly, wheeled mobile robots and humanoid robots. Application areas and some amazing facts I will tell you what is going on, and then concluding remarks. Now you will see, friends, as usual, our precision engineering and instrumentation laboratory is one among the actually 11 laboratories in the mechanical department. This is one among the working on the precision engineering and instrumentation work. We are having the 5 major research areas are there. What we will call, you'll see here, control engineering, mechatronics, robotics, vision manufacturing, hydraulics and pneumatics. Students are working in the different domains in each disciplines, as we have seen already in the many areas. Correct. Now I'll concentrate here. You'll see here in robotics, our scholars are working on the parallel manipulator, underwater manipulator, medical robots, tactile sensors, mobile robotics, robot calibration and wireless robot coordination systems. Then here, the most of the work is on the application of the advanced technology like artificial intelligence, deep learning, machine learning in coordination of the multi-robot systems. Now, already I have shown you in the last lecture, you are seeing various facilities developed in our laboratory, like a micro EDM, micro ECM, hot air jet machining, correct, friends, and extrude honing machine, and the quarter car models, and the helium pressure regulators, and the EHA systems for the space application, hydrostatic hybrid, hydraulic hybrid systems, many more. We are working in the mixed areas in our laboratory. This laboratory is only one which will calls for the different engineers and students to work in our laboratory. Now we'll see some of the facilities developed in our laboratory under the robotics area. This is first one is a self-guided vehicle, is a Harani, is the first in India developed in IIT Madras, which will navigate on the ground. Now, currently, we have developed the parallel manipulator for the underwater robotics. These joints are there, no? These joints are patented. Meaning here, these joints are used to position this top table in any orientation. Then here, middle one is a flexural tube. These are all the actuators. I'll show you some of the simulation of this thing as well as animations. And SMA actuator, one-to-one relations here. Here we are using the SMA wires to position the top table. Then here working on the, if you see the automated guided vehicles, we are using the P3DX robots and EPEC robot for the coordination work, collaborative work in the off-highway and on-highway speed control systems. Then one important facility available in IIT Madras is a robot calibration test facility, which is a furrow laser tracker, friends. Here you will see this is a very expensive equipment, about 80 lakhs. This is known as a furrow laser tracker, which will emit the laser light. And this one will rotate in all direction. I will show you animation also later. This is a retroreflector, which is tracing the path of the laser. Meaning you will attach this retroreflector to the end effector and move in any direction. Automatically, you will get it all the positions, orientations, and velocity, accelerations in the Dynacal softwares. Okay, you'll see the precision involved in the joint angle and joint positions all. This is we are using for the workspace calibration, dynamic characteristics, and errors in robotic systems to estimation. You see here, now I'm showing you this slide. These are all the ISO parameters as specified in IS 14583 and ISO 9283. So many parameters are there. All these parameters related to both industrial robots as well as mobile robots are calibrated and testing using the various sophisticated software like a CAM2 measures, Compogage, and Dynacal. Both you can do it here. Now I'll show you some of the glimpse of work conducted, carrying out in our laboratory. The thing is, you'll see here some of the work, the trajectory tracking. Here I am showing you the regular trajectories, both experimental as well as a simulation work carried out in our laboratory. This is a 2D platform, and this is the EPEC robots. This EPEC is a, wirelessly will connect and navigate on the ground. This is used to form the different types of trajectories as given by the user. You see circular trajectory, triangular trajectory, many trajectories, regular. For this, what we did, we have developed the, GUI-based modes. This is a user-friendly it is. There are here well-defined tasks are there, to move your EPEC robots. And you will give, if you are selecting the rectangle, you will give the length and breadth and linear velocity, any linear velocity will give. Then the robot will track the rectangular trajectory on the 2D platforms. These are the 2D platforms. The same thing, after this is only what we call the trajectory tracking. Next, we have extended this work to the cooperative robots. You'll see down cooperative robots. Here, the 2-3 more robots are there, EPEC robots. All are wirelessly connected, which can, to track the final destination one by one. All what we will call lead follower approach we are adopting here. Whenever the first leader, this is a leader, this is a follower. Both are moving towards the target point where you are fixing. Once it will reach the obstacle, this is an obstacle, then it will give the leadership to the second one. Then this will go. As long as the obstacle is here, then this will not move. Then it will follow the leader. Meaning the leader and follower duty is given, sharing the robot by themselves by sensing the obstacles. Here also you will see the obstacle sensing. You will place any number of obstacles and robots will move from destination the wherever you want. You will define the original point and a destination point. They will move with the required velocity and very minimal distance to reach the destination point. Okay, these are some of the papers what I am showing you, the work carried out by us. Now we'll see. Now, as I have told you here, we are adopting the different control algorithms. This is one what I am showing you is a waypoint navigation. These waypoints are there. No? There are so many waypoints are there. These are the guiding blocks, the guiding points to the robots. When you will define the source and destination, the robot will connect by themselves to reach the final destination, avoiding the obstacles. Here it will keep in mind that robot will whenever it will move from one point to another point, it will calculate the distance and the time required to reach the final destination. This will be shared to the previous robots which are coming. This is one of the thing where we are doing the work. And here you see the both experimental and simulation work carried out. Meaning it will finally you will see here this robot will searching various alternatives to reach the final destination. Finally, it will take the required destination wherever the connective points are there. This is called a waypoint navigation. Reach the final destination with a minimum time and a minimum distance. Now we'll see now also one more work what we are doing is a waypoint navigation of differential robot using the imaging technique. Here we are fixed with this is a low cost automation in which ordinary camera, Microsoft camera is fixed at the top, which will detect the robot movement on this is a 2D platform. Here we are using so many methodologies. The main methodology involved is a blob analysis, meaning here you will see here each robot is given some color coding. This color coding is detected by your cameras when the robot will move from the origin to the destination point. And the same thing, our image processing technique is validated also using your furrow laser tracker. This is very easy. It is experimentally, because when we are doing the image processing, so many problems are there. Removing the hindrance obstacles, many things. Correct. To overcome this, what we are doing, we are experimentally also we are doing this whether robot is following the required path and time using our furrow laser tracker also. These are also, you will see here, papers are available on this. Now we'll see, friends, many MTech students are working the same concept, what I will call the Bhagwan algorithms. What they will do, Bhagwan algorithm, in previous experimentation, what you have seen is avoiding the obstacles only. Here, they will do one step ahead. You see, the robot will come near to that. It will not hit the obstacle black, what I am seeing. It will make the one circumnavigate the things. You'll see, after reaching, it will make the circumnavigate the obstacle. Meaning here, you will see when the robots are working in the unstructured environment, you are able to know the shape of the obstacle occurred in the navigation. Then after knowing this, every point is stored in the computer's memory. Then afterward, it is guiding the remaining robot to follow the minimal path to reach the destination. So I am defining the starting position and the target positions. What they will do, and when the robots will come, one robot will come here, make the circumnavigate. Every instant of time, they will store the data points from the origin to the destination, which is a minimal distance. It will guide to the other robots also. Same thing, we are extending to 2 robots. You will see 3, 4 multi-robots it is. The 2 robots, as soon as it will come here near, what they will do, friends, the one robot is make the circumnavigate in the clockwise direction. Other robots will make the circumnavigate in the anti-clockwise direction. Every time, every instant of time, they will store the coordinates of each point to the destination. Then whichever is the least point, it will give the direction to the previous robots. Only they will not circumnavigate. Please remember now, the other robots will not circumnavigate. Only what they will follow the minimum distance to reach the destinations. These are as the number of robots increases and the time as well as the distance traveled by the whole robots will decreases. This is some of the remarks as we carried out the average distance carried out by the robot, single robot, two robot, three robot systems. As the number of robots increases, the total distance traveled by the whole robot and time required to reach will reduces. These are known as the bug algorithms. Nowadays, people are adopting these techniques in the working the robots in the unstructured environment. Now we'll see one more thing what we are doing now is you'll see here the goal seeking behavior of the embedded in the reinforcement learning. You will see you will define the origin point and the final point, friends, here. Then a robo will search the final destination in various routes. Here in reinforcement learning, what we are doing, we are giving the what we will call penalty and rewards. If the robo will move towards the goal, it will get the positive penalty. If the robo will move away from the destination, it will get the negative penalty. The whole thing objective is the robo will make the various alternative iterations, making it positive reward should be more compared to negative rewards. You will see here after making 30 iterations, the robo will reaching the final destinations. Also, we are doing the goal seeking algorithm. You'll see one more here. You'll see we are defining the initial point and final point. It will search various alternative from the initial position to final position, avoiding the obstacles. Nowadays, artificial intelligence techniques like a reinforcement learning or a deep learning technique are playing a major role. These are the Shanmugesh. Shanmugesh.
Yes, sir.
Connected, no? Connected. In between
Yes,
I'll
yes,
ask. Okay, thank you. Now we'll see one more thing. Some students are working on the autonomous lake cleaning, intelligent mobile robots. Here, what they will do now, friends, we are using the multiple drones fly over the lake, and they will detect the trash. We'll see trash detection algorithms are there because in the lake there are various types of trashes are there. The plastic boxes are there, plastic bottles are there, tins are there. Many things are there. Each one will be detected using the flying drones, and this will fed into the system after detecting. Here you will see one more marine robot is there. It will make the algorithms we are using the OLO algorithms, meaning it is a whole part of the development is software part as well as experimental part. The software part is algorithms to detect the trashes in the lake and which will be stored in the computer. Here we are using the what we will call bounding box coordinate method, meaning all the trashes where it is there, every coordinates are stored in the computer. This will given to the marine robots. The marine robots will travel and will retrieve all the what we will call trashes, collect it and bring to the shore. This is one of the important thing helping to the society. Okay, this is it includes many algorithms as well as a transformation matrix, waypoint navigation, many things here. Now we'll see our students are working on design and development of a reconfigurable type autonomous sewage cleaning mobile robot, friends. You will see here this very simple mechanism it is developed by our student. Here you will see this is a cutter, okay, which will be drive through the motors. So many motors are there. And these are the reconfigurable joints. Now, why it is developed nowadays, friends? Sewage cleaning is a biggest task in which now currently the man is going inside the sewer cleaner pipes and he will clean. If he'll go very farthest from the point, he will get uncomfortable to work in the sewer blocks. Now, what we are doing is these robots will insert. Then first we developed it with wired. Now it is available with wireless also. It will move in the sewer pipes. You will see these are the guiding wheels. It is. You will see here, these are the what I am marking here, the guiding wheels, which will follow the sewer pipes. When pipe dimensions will vary because different pipes they are laying, bigger diameter, smaller diameter, it will always follows the inner pipes. automatically they are adjusting. All are drive through the motors. Once the any sewage blockage is found, the cutter starts rotating, and it will pumps the water to clean it. This will goes on until it will clean whole sewer blockages. Then now you'll see, friends. Now I am showing you some of the books published by our students, modeling and analysis of electrohydraulic servo valve. Working on nanoparticle generations and surface modification of the bioimplant materials for bacterial adhesion, and many more like this. Now, why I told you is, as usual, I'm requesting all the faculty member, young faculty colleagues to join our IIT Madras, basically our laboratory, to do the lot of work in the various domains. Now, I have not shown you anything on the micro machining and fluid power system, as because I'm talking today on robotics, I have shown you only robotic related areas where our students are working now. Now, we as a research scholar in our IIT Madras, as because our Vishwajyoti College, many faculty are completed and doing their work in our laboratory also. Okay, because of many things are there here. You'll read it to our website. Now, quickly, I will move on to today's talk. Unknown to unknown, we'll move, friends. As usual, I will show you quickly. I will recall my olden days. More faculty members are there, young faculties are there, senior faculties are there. Please recall your olden days. Then we'll move to what is currently going on. If you'll see the first one, what I am written here is a photography. The only available thing during my time is a black and white camera rolls. And you have to wait 2 to 3 days, minimum it is. Or even 1 week also you have to wait to get your photo in your hand, because it requires washing, cleaning, everything you have to do it in the black rooms, dark rooms you have to do it. Okay, printing is also, it is taking more time. It is. Now we will see the photography how it is. Each mobile is having the high definition cameras. Only we will move towards the object where you want to take and click it. Very quickly you will get it the very good quality pictures. If you are not getting a good quality, delete it and do it again. But olden days it is not like this, friends. Once it is taken over, it is. Until you will replace with the new photo, you will not able to do it. Now the technology is advanced a lot. Next you will see the transport also. During my time, the bullock carts are there, horse cart, bicycle, and most popular vehicles, if you see, friends, two-wheelers, TVS Majestic, Bajaj Chetak, LML Vespa, Maruti 800. And heavy duty buses, and trucks are Tata Motors and Ashoka Leyland. Now you will see the advancement in the transport. Correct? But many of them, you are not traveled in these, some of the olden days vehicles. Now technology is changing rapidly, what I want to tell you. Entertainment, you'll see, friends, during my time, only radios. When you will go to marriage hall, all these things, gramophones. And in houses, people will maintain the tape recorders. That time we are using the cassettes for playing as well as recording. Then later you will see only black and white TV appeared in the market. Here what happened is only one channel that time launched by the government of India, Doordarshan. In between only you will get it, only one channel. In this TV, we will get half an hour regional channels are there. Kannada, Tamil, Telugu, Malayali, many things are there. Correct? But no other way you have to see that. You no need to change, no option to change it. Only one channel. Then also you will see, friends, TV that time no remote control. Meaning to change the button, you have to move near to the TV and change the hard buttons are there, not soft button like this, what you are seeing now. Many things, in olden days. If it goes on now further, you will see, friends, documentation you will see. Academic is concerned, documentation by handwriting only. There is a big competition between us, friends, to write the handwriting very good. Each students will write the handwriting in the notes different fashions. There is a big competition during that time. Later, the typewriters are there. And when I am finished my engineering, I have seen the electronic typewriter, meaning in electronic typewriter, line by line, you have to type and then print. It is very expensive offer it is. Meaning that time, what I will do, what we are doing, we are making using electronic typewriter, we are making our biodata. If something is wrong, it cannot be changed once it is printed. Meaning the price of this one is, you believe it or not, 10 rupees per page that time. Now you'll see the printing cost and how we are using our laser jets and many things, color jets. All. In banking sector, if you'll go, friends, accounting was done by hand and long ledgers are there. Each person is having one page. There they will enter all the things, how much money you are taking, how much money it is left out, everything they have to do by hand. Then later they are using the calculators, correct? The meaning here, entry and exit from the bank is taking the lot of time. Then you will see, I have seen the scientific calculator FX100 in my engineering only. That time, I don't know anything how to operate this. I have learned many things like to operate sin x, sin theta, cos theta, tan theta, how to take inverse. 1 month I took to learn along with my friends. That type of technology is there that time. Then another thing you'll see, when we want to communicate with friends or someone, only 3 options are available with us. What are those? Seek them out in a person. Meaning you have to go their house, collect the notes and come back. Or you want to communicate with them, only way is seek them out in person. Generally, what we are doing is we are going during the breakfast time, lunch time, dinner time. 100% sure the friend mother will provide the food for us. That is the thing what we are having that time. Then when we are writing communicating to our father, mother, if you are in the hostel or anywhere, we are writing a letter. The letters are speaking with the parents. Our parent letters are speaking with us. Such type of technology. We are reading the letter again and again, meaning wordings are like this. Then if an emergency basis, very quickly, we are using the telegram. Telegram is a costly affair, friends. Only some of the keywords we are using. Start immediately, feeling well, not feeling well. All these things are counted by the alphabets. Then they will charge. Later, what happened, friends? Landline phones came from BSNL. They are also very expensive. Only, rich people are having the land phones. Also, you will see now later mobile phones. Mobile phone is the belt of the industrialist or rich people. Because, that time receiving as well as, talking is a 3 rupees per call. This is, you believe it or not, this is happened in 2000, 2001, 2002, 2003, mobiles in Chennai itself. When I am doing my PhD, these mobiles, 2000 period, only industry people, rich people are having the mobiles in their belt pockets. Now you will see the technology, how it is. Every servant, every person in the world, they are having the mobiles. The cost and talking, you will see what is going on. But now, think yourself where we are and where we are heading. This is very important now. Meaning what, friends, is the transformation is taking place very, very quick. Now, no other way, we have to accept, adopt, and race to the current digital age. Many things are happening and happened in the world. Quickly, we'll see the changes in the factory layouts. That is what we will call the industrial revolution. Industrial revolution changed our social, economic, and technological status of the country. You will see now, as I have shown you in the last slide also, the first generation, what we will call 18th century, we are using the steam and water to drive our machine tools. Only that time it is a mechanical production of equipment. In second generation, 19th century, you will see, friends, the mass production assemblies, where the electricity is competing with this. We are using the electricity and telecommunication to drive the machine tools. That is what I will call mass production assembly. Then you will see third generation, 20th century, the nuclear power and various computers and softwares are occurring in the market, and we are able to use it in the industries. See here that we are using the industrial robots also to do the many works, which are replacing the human work, manual work. That's why we can call it as a automated production. Now you'll see we are in the fourth generation. This is started after 2015. What we will call, we are seeing the many future like a Internet of Things, cyber physical system, networking, artificial intelligence, additive manufacturing. Okay, we are calling this as a industry 4.0. Okay, smart manufacturing, lean manufacturing, logistics 4.0. Many names. Here, what is going on, friends? The intelligent production system it is. All our cyber physical system connecting to the internet. Here we are seeing the advanced technologies like a cloud technology, big data analytics to handle the large amount of data. The tremendous change in the manufacturing. Why it is going on, friends? This is due to the IoT evolution. You will see here, what is this IoT evolution? IoT is connecting the people, automobiles, houses, cities, and industries all together. That's because almost all machines and components in the are cyber physical systems. Cyber physical systems are the devices which are automated and connect to the internet. You remember this. Or in Industry 4.0, all are automated devices, including your robots. This is happening because of the availability of powerful, inexpensive sensors, remember, and actuators. Then mobility is a very easy now because of the weight, very less weight component. Cloud computing is there. No need to handle the small amount of data also. Everything is handled in the cloud. And increasing the computing power, meaning processor speed and frequency are increased drastically. Then big data and analytics, availability of secure open platforms are there. You don't need to worry for the data theft nowadays. People are developing much more secured open platforms to use it in the this type of platforms, IoT platforms. Now you'll see, as I have told you, currently the number of connected devices are exceeding the number of people on the earth, because each person has his own 2 to 3 devices, like his desktop, mobiles, laptops are connecting to the internet. Only one person is connecting 3. That's why you will see here, currently 9 billion devices around the world are currently connected to the internet. Correct. This number is expected to increase dramatically within the next decade, 50 billion devices to reaching 1 trillion devices. Expectation you'll see, friends. And what is the revenue here? If you see the revenue part also, $2.7 trillion to $6.2 trillion annually by 2025. Meaning such drastic changes is taking place in the IoT, which makes us to use this technology in the e-learning also. Correct? Now we are seeing online teaching, correct? You know, all Sttp, all many things are happening only due to these developments. How it is, you will see the dynamic response, smartness, compactness of the system is increased because of huge development in the VLSI technology. This is made a tremendous change in the electronic industries. Now you'll see, as I have told you, the powerful processors are there. You don't need to handle the very simple calculator also. Everything processors will do. And you will see number of transistors on a chip. Whatever the small chip we are using now, the components are increased to million, billion components on the same chip. If you see now here, I'm showing you here what is going on. You see the CPU speed, friends. CPU speed is increased from kilohertz to gigahertz. Now we are getting the terahertz CPU speed. Similarly, you will see the number of transistors when the 4-bit processors are introduced in the market in 1971, only 2,000 transistors. Now you will see not able to read. It is increased to billion transistors. Chip size is same, meaning you will see data handling is 4-bit to now we are in the era of 64 bits of data handling is possible. These are made us the our factory layout is a very powerful in communications. Correct. Now we'll see, friends. Now what is going on now? Now we'll see the transformation is taking place, even though very slowly in the recent past, drastically in a very shorter period, more than you could ever imagine. Robotics is one among them. We have seen a tremendous changes in the robotic field. What we have seen the first when the word robot was introduced by Karl Kapek in his play Roar in 1921 as a humanoid creature for a comic relief. And what we have seen currently in 2018 or 19, Endiran 2 is unimaginable and difficult to digest what we have seen in the Endiran 2 movie. Similarly, if you see what we have seen the factory layout from the standalone industrial robots, which have a fixed platform in a Ford car manufacturing company. Now robotic vehicles, as have seen many unmanned vehicles or remotely operated vehicles, meaning here, friends, here, no humans on board. And these are movable platforms and work independently and cognitively plan, perceive, and take their own action, because these are robotic vehicles are embedded devices. They will plan by themselves based on the obstacles or whatever it is. They will decide where to go, how to overcome the difficulties. They will decide. Now, ROVs are making a big sound and opens up an enormous range of applications, mainly as a ground vehicles or underground vehicles, aerial vehicles or space vehicles. So we have seen the on-water vehicles or underwater vehicles, because these robotic vehicles are used for many exploration work on ground, underground, on water, underwater, space, as well as in air. See how robots are now coming into the market. Now quickly we'll see, friends. Now please note, the vehicles require a complete autonomy to work in unstructured environment, because they don't know what is there, how to act. They don't know. They need a complete autonomy and may use a embedded human intelligence with the help of various sensors and actuators and powerful processors. Please note, friends, sensors include the proprioceptive sensors. What for it is? Used for sensing the own internal status. And also we required the stereoceptive sensors used for sensing the environmental variables. Meaning you see the big difference between the conventional tools and the advanced smart tools. They will decide the own status and decides the external environment. Then they will change their positions and orientation. On the other hand, actuators are similar to our muscles. They are real working elements. Actuators are real working elements, and their dynamic response with respond to the sensor is very, very quick. How much? In microsecond and nanoseconds. Otherwise, they will not work in the unstructured environment. So the designers are now busy in development of these sensors and actuators that should respond in micro or nanoseconds. Please note, friends, currently the 4 major research areas continue to represent the key themes observed in the international study. They are mechanisms, and mobility. These are borrowed from the nature also. Then power and propulsion. Here, how to profile the vehicles and how to store the energy, how to charge the batteries, what are the power saving things are there. It will comes under power and propulsion. Similarly, the computational intelligence, how to embed it in the machines. Please remember, friends, this is not only related to the robotics, it is related to all the machine tools in the smart industry. Smart industry, all the machine tools are the smart agent, meaning they will think like the human beings, meaning as we are embedding our human brains in the machine tools or a robots, they will think like the human beings. They will decide on spot. That's why what it is, computational and a control capabilities are embedded in the machines. How it is possible? Through the sensors and navigations. These are the four research areas where people are concentrating more on the smart, intelligent machines. Now we'll see, friends, today's chat is just a glimpse how robot was, how it is now, and how it should be. Think more beyond the vacuum for its applications. Very quickly, I will show you, friends, what is there in the fast. As we know, the robot, the word robot, this, it is a Slavic origin, and it was derived from the Russian language, robota, also known as robota, which is an executive labor, a forced labor. The Czechoslovakian dramatist, journalist Karl Kapek, in 1921 created automated substitute for the human workers. His play Rule. This is a Rossum's universal robot made up of some organic materials. You see here, Rule. These are the Rule robots, three robots. A Rule robot which resembles like a human, meaning the body is there, arms are there, legs are there, head is there, and eyes are there. That time only in 1921, the Karl Kapek bringing the many anthropomorphic characteristics in the robots. And you will see here, he embedded the feelings in the robots. Now you'll see robot, the master is giving the direction, how the robots are showing the feelings. Also, you will see here, the later robots are in the rebellion action over the master. You'll see the master is here, rebellion action. Now, what it will show, friends? Now, these are the robots? No. If you see the Encyclopedia Britannica definition of the robot, it is an instrumented mechanism used in science or industry to take the place of human being. Meaning what it is? It may or may not resembles the physical like a human being, but perform the task in the human way. Please remember. So the line separating the robotic device and automated machinery is not so easy task as we have seen the encyclopedia definition. It is automated instrumented mechanisms. Correct? Then all the machines which will work automatically are the robots. You don't ask me. These are very difficult tasks nowadays. Now I'll tell you, Olden, have you to appreciate the robots, how they are developed? Friends, have you read any science fiction novels? Shanmugesh?
Sir?
Connecting. I am connected, correct?
Yes, sir. Yes, sir.
Yeah, very nice. Now we'll see, friends, to appreciate the technological development, we have to go back. Have you read any science fiction novels? If you have not read, please read these novels. They will exaggerating the robots in many ways. You will get the real picture of robots in the Isaac Asimov novels, The Caves of the Steel, The Naked Sun, The Robots of Dawn, and Robots and Empire. You will see these novels, you will get the feelings, how robots are there. Now, similarly, if I'll ask a question, have you seen any science fiction movies? most of them you may laugh. Correct? As because you have seen many such movies, and also they are appearing in the market and freely downloadable thing from the net. All you have seen. Can you please recall and name some of them, friends? If I'll ask you this question, immediately you're telling Indiran, okay, Raw Dot One, correct? Many movies you are telling, you are recalling. Very quickly we'll recall some of the science fiction movies, what I will call Forbidden Planet. This is in 1956, this film came. It is directed by the Fred Willox. Here you are seeing you'll see here, the first science fiction icon, Robot Ruby. It is a 2.1 meter tall, exhibited the artificial intelligence that time only. You see, 1956 artificial intelligence is embedded in this, the Robot Ruby. Then you will see later Invisible Boy, directed by the Herman Hoffman. It is a also the what I will call movie next to the Forbidden Planet. Then Tin Man, a TV serial. You will see the small robot is there here on the table. You see the half-hourly TV serial directed by the Dashmal Hamlet, based on the mysterious novel Tin Man in 1933. Now you'll see Lost in Space. Many are there, many movies, correct? The TV serial again it is in 1965 by Irvin Allen. Next you will see Star Wars episodes. Star Wars is a very big episode. Now I am showing you, 4, 5, 6, 1, 2, 3. Star Wars is a big. Here you will see the directed by the George Lucas. You have seen the two robots. These are the two robots, friends, two friendly robots. This is called R2D2 and a C3PO robot, able to move around. They are intelligent. They will communicate with the human master for the comic relief. Next is a Star Wars episode 5, Empire Strikes Back. Like this, you will goes on seeing, you will see Star Wars episode 6, Return of the Jedi. Here, robots are seen as a friendly and a harmless machines. Then again, Lost in Space, directed by the Stephen Hopkins in 1998. Now we'll see Star Wars Episode 1, the Phantom Menace. Again, George Lucas. Then Bicentennial Man. Then here, Robert Williams it is. Here you see the robot is serving the food to the family. How the robots are there, you see head is there, body is there. Like easy resembling the human beings, correct? What they have shown in the movie. Then Star Wars Episode 2, The Attack of the Clones, directed by the again George Lucas. Then Hollywood movie. This is the Dinesh Babu from Karnataka. They are making the robot similar to Hero, that is a Upendra, what you are seeing here. It is like a, humanoid robots replacing the humans. They exaggerated the machines. If you have seen the movie, then iRobots, correct? iRobots. It is 2004. Again, William Smith. Then Star Wars Episode 3, Revenge of the Sith. George Lucas. Again, many movies he directed. Star Wars Episode 3, The Clone Wars. This is Dave Filoni. Next one is you have seen all Shanmugam Sundar. What is that? Directed by Indiran. Meaning Indiran is a robot. 2010 it is appeared in the market. Correct. You have seen the Rajinikanth in this movie exaggerated the robot in unimaginable way. Indiran. Later it is the Raw One. You have seen the movie directed by Anubhav Sharma. It is Anubhav Sinha. Pacific Rim. It is again it is 2013 movie. Next you will see the Transformer, correct? Next it is a Transformer in 2014. Then the Robot Overlords, the Automata in 2014. And 2018-19 is a Robot 2.0, 2.0, what I will call. Again directed by the Shankar Shanmugam. It is a most expensive budget movie, 543 crores. You see how robots are exaggerated. They are implemented the human feelings in the robot. Now, can you please tell me now, friends, after seeing so many movies, if you are read the TV serials, what is a robot? Correct? The difficult to define by seeing the novels and movies. Confusion remains in the mind after watching the movies. But no need to worry, friends. All these novels, movies, TV serials exaggerated the robot with more humanoid characteristics attached to the robot and leads to the confusion in industrial sector also, not only in the society. They will think industrial sectors, robots will replace the human employees completely and afraid for their unemployment. And so there is always a friction between the management and the workers for the robot installation. So recently, the many robot organizations like a Robotic Institute of America, International Standard of Organization, JIRA, Japan Industrial Robot Association, British Robot Associations, they have defined the robots such a way that all these definitions framed by these are giving a less importance to the anthropomorphic characteristics, but they're giving importance to two important features like a reprogrammability and a multifunctionality. Meaning, in all the definition, if you see, the robots are a reprogrammable device used for multitask. Similarly, they are multifunctional. As we have seen, if you attach end effector arm and end if arm is a one of the thing what you have seen the anthropomorphic characters to the arm, and then if you attach the welding, it is known as a welding robot. If you attach the painting robot, like this, the robot is only the mechanical manipulator. Whatever you attach, it is taken as a name. There is a multifunctional. Correct. Now we quickly will see the industrial robots. What are the developments? There are many things we look at. Robots are cooperative robots. One is hold the workpiece and another is making the drilling. Like this, many robots are there. Okay. Now we will see this. All the industrial robots are general purpose, programmable machine, manipulator, whatever you will call, possessing a certain anthropomorphic characteristics. Humanoid characteristics is an arm friends. This arm and programmability ideally suited for a many production task like a material handling application. Material handling, you will see, friends, indirect application includes what it is material transfer applications. Only material will transfer, pick and place. Correct. And another one is their direct application where robot is working with the machine tools like a loading and unloading application, part handling application, meaning assembly and inspection. Meaning this material handling is subdivided into indirect application. Indirect means they will not work with the any machines. Only they will work with conveyors. The parts and load the parts like this. In the machine loading and unloading, robots are actually working with the machines. Dedicated application. Similarly, part handling means assembly and inspection. Very tough. Meaning very tough means more degrees of freedom are required. This material handling itself divided into three main categories. Then processing application, you will see all the operations like a spot welding, continuous welding, okay, spray coating, and all miscellaneous applications like a drilling, milling, grinding, deburring, wire brushing, riveting, laser drilling, cutting. Many are involved in the processing operations. All these operations are performed with high endurance, high precision, and a high speed. Correct. Now, one more thing you'll remember, friends, in your mind. While selecting the robots or designing the robot for any operations or any application, keep in mind the laws of robots. These are very, very important. Anybody will design the robot. The robot may not injure a human being or through inaction allow a human beings to come to harm. A robot must obey the orders given by the human beings, except when such order would conflict with the first law. Third one is a robot must protect its own existence as long as protection does not conflict with the first and second laws. Then fourth law, recently 1999, Fuller devised. Here, a robot may not take a human being jobs, but it may not leave that person jobless. Meaning here, each robot is controlled by the human being, even though he will do like the human task much more efficiently and effectively, again controlling with the human beings. These are the four important definitions you have to follow while using the robot or while designing the robots. Now, when we'll use these robots, we see the many working conditions are there in the factory layout. Use for these cases only. Beyond this, you can't use it. For example, you will see the working layouts are hazardous or uncomfortable working conditions. For example, job situations where there are potential dangers or health hazards due to heat, correct, or radiation, toxicity, where a working place is uncomfortable and unpleasant. For example, in hot forging, die casting, very uncomfortable, unpleasant it is. Such cases you have to use wherever the human hazards are more. Second one, you will see the repetitive task, meaning sequence of elements do not vary from cycle to cycle. It is possible that could be programmed to perform the task. But human beings are not ready in repetitive task. But only he needs the challenging task. But here, the same work, for example, pick and place robots, some operations are machine loading and unloading, inspection, assembly, many operations will come under repetitive task. Use whenever the repetitive tasks are there, use the robots. Then difficult handling, as we know that the work part or a tool involved in the operation is awkward, hot, heavy, or delicate. It may be possible for a robot to perform the task. Otherwise, the human operator require some form of mechanical devices or handling devices to operate this. Example, as we have seen, handling of heavy work parts, MEMS parts, or a hot forging, casting parts. Difficult handling, no, that time we'll use the robot. Then multi-shift operation. The initial investment cost of the robot can be spread over the 2 or 3 shifts per day. The labor saving will result in a quicker payback. For example, you will see in the plastic molding, die casting, welding, many applications. These are the 4 important considerations you have to do in the workplace layout when we are installing the robot. Also, you will see, friends, selecting the robot for right application is very important. Don't think, friends, all robot installation have been successful. Some historical evidences are there. Misapplication of the robots, poor selected equipment, non-acceptance by the factory personnel. So what is required? Ideal application would be one which possesses the 4 general characteristics like a hazardous thing, repetitive, difficult handling, and multi-shift. Use the robots. Please remember, economic analysis is must, meaning what is a cost reduction and what is a productivity improvement by installing the robot is must before going to use the robots. Now you'll see, friends, some of the notable examples of the robots in industry very quickly. Material transfer application, meaning what it is, friends? Pick and place. Low level of technology is sufficient here, material transfer. If you will supply the work parts in the proper orientation and proper position. What robot will do? Robots will pick and place. But keep in mind that how much force we have to exert on the gripper is decided by the load carrying capacity. Here you will see they are handling the bulbs, very delicate parts, meaning robots can handle very heavy to delicate parts. There's so many sensors and actuators are embedded in the machines. Similarly, you will see the palletizing application. the work parts are moving over the things. For example, you will see here milk bags are moving. Then robot has to pick one by one and place it in the box, meaning higher level technology as compared to pick and place. So one more degree of freedom is required to pick the parts properly and place it in the box. Once the box is full, automatically it will move to the warehouses. Similarly, the depalletizing. Depalletizing means all boxes are coming. Loading should be done one by one from one reference. It will unload all the parts. Again, one more degree of freedom is required for the robot. Machine loading and unloading technology. Robots, you will see the one robot. This is called as a robotic work cell, friends. Here, what it is include, basically the robotic work cell consists of the single robot. So many production machines are there, and some form of delivery systems are there. Then what it will do, the same robot is serving 2-3 machines at a time, meaning you will see such type of robots requires the higher level of degree of freedoms and higher level of intelligence as compared to pick and place robots. Now you'll see some of the major applications where human hazards are more call for the robot application: die casting, plastic molding, forging, machining operation, stamping. Yes. Then you will see some of the process applications. Spot welding is a very prominent application where industrial robots will used. Here you will see spot welding means the robot will move up and move down, make the spot welding. It is a low level control. There is a synchronization is there on the moving car and the robot movement up and down. It is a spot welding. Then you will see the high level control is required for the continuous arc welding, because robot will detect where you have to put the more material, where you have to put the less material during the welding. What you have to detect. That time you require one more degree of freedom. Vision is included here. Previously, no, not required. Meaning based on the application, spray painting, again, it is a high level of control, meaning it should paint the parts properly, all directions. Okay. Then you will see the other machining operations like a drilling, okay, milling, polishing, grinding, deburring, much more. Many applications, you will see water jet cutting, many applications are there. And one more is, as I have told you, parts are handled on assembly robots. All the assembly on the car bodies are done through the dozens of robots on either side, like a painting robot or a welding robot. Same, they will pick the one by one, they will assemble. Finally, you will see at the exit final part. I'll show you again one animation of this later. Inspection robots, all parts will be inspected using online as well as offline based on the techniques what you are using. If you see, friends, the statistical use of these industrial robots, you see here. This is statistics. See here, the whole robotic family used for material handling 25%. Either it may be the pick and place, palletizing, depalletizing, machine loading and unloading, anything. 25%. Then spot welding and arc welding is a second and third category. Spray painting and a finishing is the next category. Machining, mechanical assembly is what you will do, no? 6%. Electronic assembly, 6%. Material removal, machining process, 4% alone. Inspection and testing, 3%. Water jet testing, 3%. And others comes under here. You will see here, the statistics will show you that wherever the repetitive tasks are there, human hazards are there, multitasking is there, that time robots is well suits industry. Correct, friends? Now we'll see the other advanced application, what we will call autonomous robots. Autonomous robots can perform the desired task in unstructured environment. Please see here, unstructured environment without human guidance. Meaning what it is, friends? They required high degree of autonomy is particularly desirable in fields such as space exploration, okay, cleaning the floors, moving the lawns, wastewater treatment, correct underground, What is required? High degree of autonomy is required. So what you have to do? The computational intelligence is embedded in the physical machines, creating the system with capabilities far exceeding the core component alone. That is, able to carry out the tasks that are unachievable by conventional machines or even by humans working with conventional tools. The ability of a machine to move by itself, meaning autonomously, opens up an enormous range of applications that are uniquely suited to robotic systems, meaning the exploration of resources on the ground, underground, in the air, in the space, under the sea. So, such vehicles are called unmanned. Unmanned means no humans on board. In general, these vehicles move by themselves under their own power with sensors and computational resources on board to guide their motions. Now we'll see why this autonomous vehicle, you may ask. You'll see now here, one example I am given here. Research in the US on remotely operated vehicle used for deep ocean exploration revealed the discovery of the sunken Titanic. They will discover sunken Titanic is there inside the sea from so many years. Many people are buried here. You see the exploration leading to many discoveries. Also, you will see, you may ask where, and why robotic vehicles. The many reasons are there, friends. I am listing you 3 important reasons where these robotic vehicles are used. Mainly where people cannot go or where human hazards are more. Such applications are called first class of robotic applications, which includes many space exploration, undersea world, nuclear and biological contamination sites, military operations, security systems, and defense systems, much more in the first class of applications. If you'll see now, similar to previous second class of robot application, the routine task where machine mobility can effectively replace the direct human presence, like a large-scale agriculture, requires machine to cultivate, seed, irrigate, and harvest very large areas of terrain very quickly. That time robot is best. Then mining halt truck, then insect killing machines, environmental monitoring devices, the large manufacturing concern to transport the components and sub-assemblies from one place to another. That comes under the second class of robot application, meaning routine task. Similarly, we'll see the third class of robot application used for the personal assistance, rehabilitation, and entertainment of the robots. Here, many devices are developed in the third class, which will helpful for the persons. Robotic wheelchair, you are seeing, mining halt truck, elderly care through feeding, household task, and emergency notification. The vacuum cleaners and lawn movers. Many things are helping the elders. Similarly, the advanced entertainment systems, meaning locomotion of humanoids and biomimetics, are used for entertaining the people. Correct? Now, again, you will remember, friends, when designing these autonomous robots, similar to the industrial robots, where is a fixed platform, there is a movable platform. Again, keep in mind the rules of autonomous robot. What are those? Gain the information about the environment using the sophisticated sensors. Then work for an extended period without human intervention, because the vehicles used in the space exploration, underwater exploration, they will work for 6 months, 1 year, meaning it will working extended period of time. Similarly, move either all or a part of itself throughout its environment without the human assistance. Then avoid a situation that are harmful to people, property, or itself, unless those are part of the design specifications. Whatever it may be, friends, autonomous robots still require the regular maintenance, as do other machines. Now, quickly, I'll show you some of the robotic automated vehicles, like a, see now, friends, unmanned ground vehicles, which will move on the ground. You will see here Gladiator, dune buggy with machine gun. These are used for the defense. Unmanned aerial vehicles, you will see for the high altitude RQ-4 Global Hawk. Then surrogator operated vehicle. Then MQ-8B, this vehicle is used for the most of the things are fixed wings. You'll see here fixed wing. This is a rotating wings. All types of robots, the form of borrowed, used for the nature, they used for the explorations. Correct? Now we'll see the micro air vehicles. The size of these vehicle is very, very small, friends. Like 15 centimeters totally. The weight is 100 grams, used for the various exploration task. Similarly, you will see underwater world, the vehicles are used for ocean explorations with optical cables and many things, many more. Whether it is restricted this thing? No. It is extended to the surgical robots also. Here, robotic carts are used in heart surgery, kidney transplantation, eye surgery, brain surgery, neurosurgery, orthopedics, radiosurgery, urology, pediatrics, gynecology, and much more, friends. Robotic carts are used for with the surgeon. You may ask why these robots in surgery? Because they can cause a less damage and less bleeding. Hence, quick recovery is possible with robotic surgery. Also more accurate than the human surgeon. In this category, you will see these are the robotic carts. I'll show you in the next slide also. The two most popular robotic carts are used. One is what we will call a D-Vinci surgical system, and one more is called Jesus robotic surgical system. All these two devices are handled by the surgeon sitting in the one room. The robot will do the instructions given by the surgeon. Mukesh?
Yes, sir.
I'm connected, okay?
Yes, sir. Yes, sir.
Yeah, thank you. Now we'll see, now robots are used as a mobile robot, as I have told you. It is a future medicine by nanorobots. This is making a tremendous change in our day-to-day life, like a drug delivery systems. Biopsy, they have done through these movable vehicles. Now also you will see the endoscopy. You have seen endoscopy, wired and tablet endoscopy. Meaning in wired endoscopy, the wire is inserted around 2 meter or 3 meter. They are inserted in yours through the mouth, and very difficult, friends. Okay, camera, it will carry the so many optical cables along with camera. The doctor will take around less than a minute to investigate in the stomach. Correct? Any wounds are there, or many things. But now in the capsule endoscopy, what they will do, you will take one tablet, then automatically doctor will capture all the images. Then you don't need to worry, camera will come by themselves next day. Meaning the technology is advanced in such a way that also you will see in some of the asthmatic patients, that directly the tablets are there. If you take, that will go to the lungs and they will open up. Meaning they will deliver the drugs where it is required. In a drug delivery system, it is one of the important things used by the nanorobots. Also, you will see in the sugar patients, no, they are sometimes they forget to take the medicines. They will implement these devices, loaded devices, automatically based on the insulin rate, all automatically they will open and deliver the medicine. These type of things are going around the world. Now you'll see now some more things. Robotic world of the future. You'll see like animals, robots are developed. You'll see how the legs are there, how body is there. Robotic world of the future is now we are thinking for the coordination of the multi-robot systems. Meaning it is a new approach which consists of a large number of mostly simple physical robots. Like you'll see here, these are the epic robots. This is derived from the closely related swarm intelligence. Meaning what they will do, initially inspired by the studies of social insects. When one sugar candy lies on the ground, what they will do, the insects will guide the previous robots, previous ants. They will move one over the other to take the sugar candy to their place. Swarm intelligence also like this. Each robot will guide by themselves to the previous robot. This is very useful in the automated guideway vehicles. This is a technology borrowed from the biological inspiration and take the form of an emphasis on the decentralized local control and communication. There is a main theme behind the swarm robotics. Now, one more thing you will see, friends, self-reconfigurable modular robotics. Whatever you are seeing here, you will see this is called a kinematic jacks. All are automatic building blocks. They will detach by themselves and they will attach by themselves to take the form of any shapes you'll see here. This is a new technology. People are using the self-reconfigurable robotic blocks. These are the building blocks to do the various works. I'll show you this also animation if time permits. Now, next one is a humanoid robots. The scientists in Japan are now engaged in developing the technology far behind the what we are thinking by developing the robots like caretakers, general servants, technicians, engineers itself. Meaning technology has already been developed and used in the robotic vehicles in terms of eyes, hearing capability, arm, leg. They will function like the human beings, friends. The latest advances in robotics involves placing the incredible sensitive sensors all over the body of robots that emulate the tactile response of a human skin, meaning a development that has far-reaching and profound implications. The fingers of this new order of robots are just as sensitive as a human fingers. Robotic world of the future, walking, talking robots demonstrated at the Expo 2005. I attended this. The time has come when the laws of robots devised by science fiction writer Isaac Asimov in 1940 should be dusted off and turned into non-fiction laws worldwide. As because the laws are made to be broken. The robots are developed like a human beings. Only left out thing in the humanoid robot is implementing the feelings. That is also taking place shortly. Now I'll show you some of the humanoid robots you're enjoying. You see here Toyota Motor partner robots in action here. These partner robots are seen at the Toyota Motor Company showroom in Tokyo, Japan. Now we'll see My Spoon, the Japanese health minister. It is an assistive device, the My Spoon, during the demonstration of healthcare robots in Tokyo on November in 2008. My Spoon is developed by the Japanese company to help the disabled people. Only you will open your mouth and close, the robot will feed the food items. It will pick from the box and it will feed. Only you will open your mouth and chew it, nothing else. Okay, robots are programmed in such a way that. Now we'll see some more thing. Dynamic balancing wheeled robots at NASA, Toyota, and MIT. These are all dynamic balancing. Even though you'll push it, they will not fall down. Such things for the entertainment developed. Similarly, you will see, friends, the Sony and Fujitsu humanoids. They will work in coordination to entertain the people. Now we'll see one more thing is a farmer rickshaw it is. The farmer Ulu drives his auto rickshaw pulled by his self-made walking robots. Similarly, you'll see the Rollin Justin, you may have seen these things preparing the tea and coffee for the people. Then robot mobile saucers robots. Then Hyundai, you will see they are developed. Again, it is a height of this robot is 130 centimeter, weight is 40 kg, degree of freedom is 57 degree of freedom is there. Running speed is 9 kilometers per hour. This is entertaining in the Honda, the expo. You'll see robot how it is dancing and how it is listening the music and dancing. Now you'll see these are the robots unveil the next generation Shimo robots. Now you'll see in the robot morphology, you'll see, friends, to work for the research. The robots are available in the smaller to bigger for any shapes. You will see Capro robots. Again, it is a reprogrammable wireless robot. The Pioneer robots having the so many sensors integrated. Again, it is a 3DX robot for used for the ground vehicles. Biped robots, quadraptor robots, hexapod or octopad robots. Many robots are available in the different shapes. Now I will tell you some amazing facts about the robots. You already know that the word robot comes from the Russian language, Jek, Febota or Robota, executive labor or a forced labor. It was first used in the 1921 Karl Kapek's movie. This is a play it is, Russell's Universal Robot. Fact 2 is a first robot homicide occurred in the Ford Motor Company where first robots are used. In the casting plant, Robert Williams, January 25, 1975. This is a person killed by the robot, homicide. Over the past 25 years, 61 robot-related injuries and deaths were reported in the US alone. Please remember, friends, if you are not programmed properly, if you are not used properly, the evidences are there, robot homicide occurred. Then you will see the first humanoid robot was debuted in 1927. Herbert Leox, built by the Ron 1927. This is what we call Westinghouse Electric Company developed the first humanoid. The later people are thinking it is a Electrolux is the first robot, but this is a first. It was a 7 feet tall and 120 kg and could speak 700 words. Now see, the fact number 3, robot will emerge on their own. This is a new, as their own species by 2040, according to the Hans Marwecki, founder of the Cornell Million Robotics Institute. They will emerge by themselves. So we'll see Taliban fighter disables the robots used by the US military by clipping ladders onto them, thus defeating something high-tech technology with something low-tech technology. The number of use more than a millions, and over half of these robots are based in Japan, the epicenter of technology, and country predicted the revenue around 70 billion US dollar by 2025 with these robots. The world's first cyberlock is a Professor Kevin Warwicki, who uses a chip in his arm remotely operate doors, artificial hand, and electronic wheelchair with the help of sensor. When he will see here, when he will move fingers up and down, it will also move. This is a first cyber lock. Then first time robots were mentioned when Leonardo da Vinci referenced and stretched mechanical night in 1955. NASA has since credited his robot. You'll see robot how it is previously. It is a skeleton. It is the first time robot was mentioned in 1945 itself. The first working robot, as I have told you, made for the cars as a part of the production line at a car giants Ford back in 1961. The smallest robot is called a nanorobot. It measures 10 nanometer in size or less than 1/1000th of the millimeters. Now we'll see, I'll show you some more robots, the intelligent robotic systems in aircraft, in airports, many places, how it is implemented, robotic technology. Here, what I am showing you here is a autonomous check-in robot kiosk developed by the Sttp, meaning what it is, autonomously move to busy or congested areas in the airport, the check-in counters, reduce a passenger queue times at a check-in. Here, what you will do, you will feed the PNR number or your ticket or your passport if you're international traveler. Automatically, it will issue you the boarding pass. No need to wait in the queue. They are also implemented in many of the cities in India also. Then you will see here the baggage drop developed by the Sttp. Here at a departure terminal, here these type of mobile robots are there. What you will do, scan your ticket here and get a baggage tag and tie to your bags and forget it. You will get the baggage at the destination, meaning they will load your bags to the respective. You no need to worry. Directly we will go to the check-in counters. Also, you will see some of the things I am showing you here. The Beijing airport. Here you will see it is a next generation airport. Here you will see the interactive robots are there. They will give all the information like a departure terminals. Then, so many cafeterias where it is, restrooms where it is. All information you will get on the interactive kiosks. Also, you will see, friends, when you will enter the airport, no need to search for the parking place for your car. Only you have to move over the car over this mobile robot. This is a platform. Then you will get the barcode for your ticket. Then you leave it. Then automatically it will search the empty space and it will park your vehicle. No need to worry. Such type of mobile robots are coming. Similarly, you will see, I have shown you so many things. Ant swarm robots, you will see technology, how it is borrowed from the ant. Similarly, ant legs, you will see all these things are embedded in the robot. Then also you will see how it is picking, all robots will picking by coordinatively moving this thing. The e-motion butterfly robots. Sto is developed this. Then flying fox, meaning technology is borrowed from the nature to implement. Boston Dynamics Laboratory will see they will develop the humanoid robots moving from one place to another place, opening the door, keeping the items in the racks. Everything it will do by the instruction by the operator. Similarly, they developed the dog robot, how it is climbing and how it is moving very fast like a dog's and climbing the stairs. The robot shark study the creatures in the what I will call oceans. Robotic shark, cabled one it is. See here, the other shark how they will follow the instruction, guiding principles, motions. They will study sitting inside the ship. Then you'll see robots are used in the cafeterias for making the coffee, egg omelette, anything. This is, you'll see the more of a gantry type of robot it is, like your two human hands to preparing omelette or anything. These are very popular in the foreign countries. They will prepare the food and they will serve. So friends, you'll see now here, robotics is transforming the world faster than you can imagine. I think some more areas are left out for robots. No limits, sky is the limit for its applications. Now, quickly, I will conclude this. Technology is now driving force behind the evolution. As new and better things come out, we have to adapt to them, not to resist, because sometimes change our entire lifestyle. Robotics is a hot field which continuously makes the news. Unmanned vehicles are putting more and more our distance between our troops and a dangerous situation. The notable recent advancement is a robotic arm, prosthetic arm, swarm robotics, humanoid robotics, much more. As usual, your friends, many faculty colleagues, the new NPTEL courses I'm launching this current semester. It is open for the registration, and faculty colleagues who are teaching this and your students who are interested, let them register. Within a 15 days, 225 students are registered for this course. It is a rigorous course it is. I tell our students to register for this. Thank you so much. Thank you. Shanmugesh?
Yes, sir.
Yeah, now I'll show you some videos and then let them ask. Okay, another 5-10 minutes is there. I'll keep for this, only 1 minute. Okay, I'll share the videos. Tell me whether this is done in our laboratory. Okay, what I'm showing you now. Friends, I'm showing you the parallel manipulator. Now, how to do it now? This sharing, correct? Stop sharing and then share. 1 second. Stop sharing and share the videos. Okay, first I'll see this. Whether it is seeing now? See, Shanmugesh?
No, sir.
Now you'll see? Oh,
No, sir.
no, 1 second.
You share the entire screen and then shows it.
1 second. Only 1 minute, please. It is in the inside the folder. Is it okay? Now inside the folder is no problem, correct? Share the entire screen. Okay, now we'll see. I'm showing you 1 second. 1 second. See, this is a parallel manipulator used for the ocean exploration. We are testing this robo on the ground itself. Shanmugesh?
Yes, sir. Now it is okay, sir.
See here, these guns are patented one. This top platform, and the down is a movable platform. This is controlled through the motor. Here actually, this is a flexible seat. Controller. So more I'll show very quickly. Then you'll see this is a medical robot. Created in our
Yes, sir. Okay, clear, sir.
a medical robot. We are calibrating our laboratory using the furrow laser. This is retrorefractor where we are. Very quickly, I'll show you some more. No time for us. This will see the what we will call obstacle avoidance technology we're implementing. See this? This is circumnavigating the obstacles. It will give you the clear picture of what type of obstacle is there. I don't know bug algorithms how we are implementing. It's a single robot system. It's completely up. Two robots will come. Near to that, one will make the clockwise, and another make the anti-clockwise. Very quickly, I'll show you. Bug one full. Okay. See, it will not hit. This adjustment, the adjustment between the obstacle and this thing is possible to do it. Now I'll show you very quickly one more, tracking. You will see now how accurately it will be. Any trajectory, any shape of the trajectory. The computer you have to feed as a GUI. Now he is editing the radius and the velocity. Any trajectory you have to track. Wireless. Look at how circle is tracked. This is a epoch robot, programmable type. Yes. And Shanmugesh, last one I'll show you. This is not from our thing. Corolla University, they are developing the self reconfigurable robots. Just building blocks, as I have told you. They are called self reconfigurable robots. Shanmugesh. Shanmugesh.
Sir.
Shanmugesh.
Yes, sir.
I'm in proper way, correct now?
Yes, sir.
Now I'll stop my talk.
Thank you, sir. Thank you.
Yeah. Thank you very much for giving an opportunity.
Session.
Yeah,
So,
but I'm very you know, yeah, now we are facing a lot of problem in taking online, you know, physical seeing the people, correct? That is the biggest problem it is now. Sorry for that, you know, some other occasion all will meet in the Sharmigesh College if opportunity permits later, correct?
Thank you, sir. Thank you.
Thank you very much. Thank you very
Thank you
much.
for the wonderful session. Let me invite Mr. Eldos Kurian for the vote of thanks.
Yeah, thank you. Thank you very much.
Okay, sir. So we all had a wonderful session on this robotics by Dr. Somashekar sir. He explained the different aspects of robotics in a very practical and lucid way. So on behalf of the department and on behalf of the college, I extend my gratitude to Dr. Somashekar sir. Sir, thank you.
Thank you very much. Thank you so much. Thank you.